Hi kids, 7.3 is square root functions and inequalities with square roots. Let's dive right into a square root function. Think about a function. Y equals the square root of x. Let's plot a couple points because you should be able to understand this graph very, very easily. So let's say we're going to plot -1, 0, 1. Let's leave it at that for a second, and let's think about plugging in -1. When I plug in -1 for x, I get the square root of -1, and I don't graph imaginary numbers, so I can't actually have x being -1. As a matter of fact, I can't have x being any negative number. So the first one I can plug in is 0. That's the smallest number I can plug in. Well, what's the square root of 0? So when I plug in 0, I get square root of 0. Well, what times itself gives me 0? I hope you knew it was 0. Now, when we plug in the next one, 1, the square root of 1 is what? What times itself gives me 1? Well, it's 1. And remember, when I am not taking the square root of two sides of an equation, I don't do plus or minus. I only do plus or minus if I'm taking the square root of both sides. But if you just ask someone, what's the square root of 1? The answer is simply the positive number 1. Now, am I going to want to plug in the number 2? Well, I'll get a decimal, so maybe the next nice number to plug in would be 4. Plugging in 4 gives us a square root of 4, which is 2. Let's plot these points. 0, 0, 1, 1, and 4, 2. What would be the next nice number to plug in? I hope you think of it as being 9, giving us an answer of 3. 5, 6, 7, 8, 9 gives us 3. I know I'm not putting dots on this, but do you see that the graph will look like this? It won't go anywhere to the left of 0. It will only go from 0 to the right. And it goes up slowly because 9 went all the way out to 3, but it only, x went all the way out to 9, but it only went up 3 units. So it looks like this graph. And so that brings us to this key concept that the parent graph, a very common graph, is y equals square root of x. And that it looks like this. The domain are x values that are bigger than or equal to 0 for the reason we just talked about. Look at my xy table. I couldn't use numbers less than 0. Graphically, think of it as only numbers from here to the right are being used. So x values that are positive or 0 are being used. What about y values? Y can only be numbers bigger than or equal to 0? Yes. These all coming out are 0 and up numbers. Graphically, the graph is not drawn down here, so no y values that are negative are used. The intercepts are basically 0, 0. It's not defined over here when x is negative. And the end behavior is this. As x approaches 0, the y approaches 0. So in other words, as x is approaching 0, the y is approaching 0. And then as x approaches positive infinity, the y is going upward ever so slowly, so it's going toward positive infinity. Now, you have to learn this. This is really going to make graphing so much simpler. The function, square root function, looks like this. A, which again affects the shape as far as being vertically compressed or vertically expanded. But we have x minus h, whoa, let me end my parentheses and plus k. These are the same translations that were used before. So the k, if it's positive, the plus k is positive, it means it got shifted up. If k is negative, it gets shifted down. The h, remember the h, left and right? If h is positive, so in other words, if this is x minus 3, it gets shifted to the right. And if h is negative, it gets shifted to the left. And then a will change its shape and orientation. If a is negative, it gets flipped across the x-axis. And then if the absolute value of a is bigger than 1, it gets vertically expanded otherwise vertically compressed, but we'll deal with those as we move on. So keep your book open to this page as we do some graphing. Okay, identifying the domain and range. To be honest, I usually, I guess I like how they're doing this. Okay, no, I guess I like it, kind of. I honestly like to graph the graph first and then come up with the domain and range. I will just say if you like how they're doing it in example 1, you know, you're welcome to use this. But I'm going to go ahead and determine the domain and range of each of these functions. To be honest, it's easier for me to just graph this thing as opposed to come up with a lot of algebra to identify the domain and range. Let's look at this graph. Remember, normally the square root of x would go through 0, 0, 1, 0, 4, 2, and 9, 3. It would be, and then numbers in between too. Remember, you can still have decimals. This thing just says shifted to the left, to the right 5 units. So now the graph looks like that. So the domain, what x values are being used? X is numbers bigger than or equal to 5. And what about the range? What y values are used? Y values are bigger than or equal to what? Look at the y-axis. What numbers are being used? Numbers from 0 up. Let me highlight and show you. From this point up, you can see the graph. So look at the y-axis. From 0 up, you have a graph. Similarly, x values from 5 on, you have a graph being used here. So from 5 on. Now how they showed you to do is say, well, whatever is inside the radical has to be bigger than or equal to 0. You can't have a negative number. So if you add 5 to both sides, you get that. And that's kind of how they got the domain. And then for the range, what they did is plugged in the 5 to find out what the y value would be. Let's look at 16. Again, for 16, I'm going to just graph it ever so quickly. You won't even believe this. I'm going to take the regular square root function, 0, 0, 1, 1, 4, 2, 9, 3. And I am going to shift up 5. Whoopsie. Because of the plus 5, I'm going to shift up 5 and to the left 2 units. Now, if you don't believe me, plug in the point -2, 5. I believe that is my vertex right there. -2 gives me the square root of 0 plus 5, and that's just 5. So plugging in -2 gives me 5, and I'm really excited about that. I agree, that's 1 point on my graph. The domain, what x values are being used? Well, look at the x-axis. Numbers from -2 to the right. So x is bigger than or equal to -2. Again, I could have found that number by looking at the expression under the radical. And then the range. What y values are being used? Well, the graph starts here and goes up. On the y-axis, that's a 5. So y is numbers bigger than or equal to 5. Okay, 18, I guess same thing. Find the domain and range. I'm going to graph it. I'm not quite sure if they want us to graph or not, or what the directions were for 18, but I'm going to graph it also. Now I have a lot going on. I have a negative sign in front and a positive 5. So what I'm going to do is graph what I think is happening, and then I'm going to check it by plotting some points. So I'm going to take this part and then add 5 as like a last thought kind of thing. We tacked on a plus 5 at the end. So remember, my original graph looked like this. It went through 4, 2, 9, 3. Okay, it looks something like that, and it goes off to infinity. The -6 means that the graph got shifted to the right 6 units. Then the negative sign in front means instead of going up, it's going to go down. So it looks like this now. And then we shifted up 5 units. So I'm going to take the blue one and go up 1, 2, 3, 4, 5. I believe this is what my graph looks like. So I'm going to erase all the others. Now don't forget, I'm graphing it on graph paper that's numbered. Make sure you have numbers on your graph paper. Up, 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 up. So I believe this point is 6, 5. Let's plug in 6. Do we get 5? We get negative square root of 0, which is 0 plus 5. And yes, it does equal 5. So first of all, I'm really excited about that point. Let's plot another point, like 10. Why did I pick 10? Because then it will give me the square root of 10 minus 6 plus 5. That gives me the square root of 4. Oh, that's why I picked 10, because 4 is a perfect number, perfect square. So then I get negative 2 plus 5, which equals 3. So if I plug in 10, I should get 3. Well, that's up here. And so basically, yes, I'm super close to the graph that I thought it would look like. So there's my graph looking like that. I knew that it got reflected. It got moved to the right 6, and it was shifted up 5. So what is the domain? The domain are x values that are bigger than or equal to 6. Look on the x-axis. The graph goes from here to the right. So on the x-axis, that was 6. See x to 6 to the right. And what about y values that are being used? Is the graph drawn up here? No, it starts here at 5 and it goes down. So y values that are less than or equal to 5 are being used. Okay, they want us to keep doing the same thing. Graph it and then state the domain and range. Now they plot a bunch of points. I think that's a waste of time. I'm just going to shift up, down, left, and right and make adjustments for that 1/2. So let's pull up some graph paper. Don't forget, I need to see this on graph paper. I plot a normal graph, 0, 0, 1, 1, 4, 2, 9, 3. Keep going. There's my normal graph. I do plus 4, which means it gets shifted to the left 4, and then minus 1, which means it gets shifted down 1 unit. Well, the 1/2 is really going to change how steep this is, and I propose that it's just going to be taller or shorter. So what we're going to do is plot a couple points. I'm going to plug in negative 4, and what I get then is 1/2 times negative 4 plus 4 minus 1. That gives me 1/2 times 0 minus 1. So the coordinate, plugging in negative 4 gives me negative 1, which is what I have right here. Let's plug in 0, though. What happens when I plug in 0? 0 is a good number to plug in because that gives me the square root of 4, which I like. So this is 1/2 times the square root of 4 minus 1. So that's 1/2 times 2 minus 1. And 1/2 times 2 is 1 minus 1, which means I actually get 0. So instead of getting 0, 1, I plugged in 0 and I got 0. 0, 0 is the actual curve. So I can see the graph goes like this, much narrower than it did before. So I am going to cross out the original one for my teacher and say, this is my f of x. I have a couple points plotted. Maybe I would show a little bit like I did. Negative 4 gave me negative 1 and 0 gave me 0. Just to show I knew the general graph, there it is. I knew which way it opened up or down, or and then I also knew some specific points. Oh, so what is the domain? What x values are being used? Here's the x-axis. X is numbers greater than or equal to negative 4. And the range? Well, y values are used. Y are numbers bigger than or equal to negative 1. Okay. A couple more examples. This is going very quickly, I hope. Here we have a square root function. So in our heads we think 0, 0, 1, 1, 4, 2, 9, 3. And we're going to shift it to the right 4 because of the -4. So to the right 4 and then down 10. Down 10. So the graph looks like this. So what is the domain? So of course I graphed it on graph paper with numbers. The domain is x's numbers bigger than or equal to this number, 4. And the y value is what? Numbers from -10 upward. Range, I was going to write y. Y is numbers greater than or equal to -10. Same with this one. I start by plotting 0, 0, 1, 1, 4, 2, 9, 3. This thing gets shifted to the left 7. Then I'm going to flip it, but I'm going to keep in mind that that 3 is going to change the shape. So now it's going to go down. And then I add 9, move it up 9. Oh. So what that ends up looking like, now it's not going to be perfect until I start plotting a few points up 9. So I'm going to erase the other ones, and I'm going to work with this, and I'm going to plot some points. So x, y, I'm going to plot -7. I know that's going to be what I have here, so it's -3 times basically 0 plus 9. So that's going to give me 9, and so that's why I have a point at -7, 9. Well, what would be another nice x value to plug in that would be a perfect square under the radical? Well, I could either pick -3. Well, sure, let's do that. -3. Why did I do that? Because I know that -3 plus 7 is 4, and 4 is a perfect square number. So that gives me -3 times the square root of 4 plus 9. So it's -3 times 2 plus 9, which is -6 plus 9, which is +3. So plugging in -3 gives me +3. Oh my gosh, that thing is really much steeper down there. Let's plug in another x value. I'm going to actually move this down so I have more room. What would be another good x value to plug in? I hope you're thinking 2, because if I plug in 2, I get 2 plus 7, which is 9. And 9 is a perfect square. So this is -3 times 3 plus 9, which is -9 plus 9, which is 0. So plugging in 2 gives me 0. Oh, that means the graph looks like this. So forget this one. It is much steeper because of that -3 value. So what was our domain? X had to be numbers, let's see, from -7 to the right, greater than or equal to -7. And what was our range? Range or numbers, y is less than or equal to 9, because it was up here going downward. The graph is not up here anywhere. Oh, sorry about that. I knew I clicked something. The graph is not drawn up here anywhere. Okay, square root inequality. The square root inequality involves square roots that are graphed using the same method as other inequalities. In other words, once you graph, I'm not even going to do them, but once you do a graph, which this one would be shifted to the left 6 units, and y is greater than that, you just shade everything above. And remember, if it's greater than, you have to dash your line and shade above. Now, when you shade above, another thing is you're going to shade up here to this point. You are not going to shade over here anywhere. So if your graph starts here at -6, which it does, that's where my shading begins. And it goes off toward the end of my graph. If I'm going to draw it out to here and put arrows, whoopsies, dashed, then my graph would go like that. If it's greater than or equal to, you use a solid line and shade above or below. If it's greater than, you shade above. If it's less than, you shade below. All right, well, have a wonderful evening, guys. Wanted to keep this one short and simple. If you have any questions, please make sure to let me know. Have a great night.